So today we're going to be starting with a new project inside the IO. So today we're going to be starting a new project inside the IO configuration utility program software. If you're familiar with programming the Edwards IO system, this video is for you. So the first thing we want to do is we want to go up to project and we want to start a new project. We click on new project over here to the right. We're going to give the project a name. And once we click OK, project is set, and we could double click on the project to open up the actual project. So inside the project here, we have our project window. We could put our contact name, our address. We can input our city, state, postal code, phone number, fax, email address. We can input all of that information in here. But what we want to do is we want to go into configure and we want to add a panel. Now this is an older version of the IO. If you have the newer version, you'll have an IO 1000. So what we're going to do is we're going to select the IO 500 for this demonstration. So here's the front panel of the IO 500. This should kind of look like what you see in the field with the reset, acknowledge, the silence button, drill, the remote disconnect button, and we have these two buttons here that can be programmed to do fan restart or to um, stop the horns and strobes from going out, like disable the outputs. So once we add the panel, we're going to have to, if you're a technician in the field and you're programming a system, you would have a set of drawings, and these set of drawings will have devices on them: smoke detectors, the location of the smoke detectors, the pull stations, the modules, whatever's being installed in the building, a big system or even a small system, will have devices for you to program inside of this fire alarm control panel. So what we're going to do is we're going to go through all the menus from contact all the way down to devices and add some information. So this is how I would build a system for a customer. So inside the contact, I will put the company's information, put our address. So now that I have all of the information inside of the banner, so anytime that we pass this along to another technician, so now that I have my information in the banner, if this system gets taken over a few years from now, someone upload this panel information, my information to be there. They can reach out and contact if they have any questions or any software issues. So that's how you will input your information into the contact side. So on the banner side is where you will put the building address, the building's name, system normal. You will put some information here that's going to be displayed on the front panel. So here we're just going to put system normal. Because you can have 123 building lane, whatever New York zip code. So, but you could put the physical address, but we're just going to put system normal to leave that generic. So now we go to the NAC circuits. We have 4 NAC circuits in New York City. The horn's supposed to silence when you hit silence, and the strobes are supposed to keep flashing. So for us to make that happen, we have to select a point type in order to make that happen. So the point type for that will be Genesis silenceable. So let's see what that means. So the point type Genesis silenceable clicks this NACS. It says this NAC type if you want to output synchronize since the Genesis silenceable point type for the output NAC circuits is if you want this output to be synchronized that only turns off the horns when you press signal silence, then you use this point type. This will enable the strobes to keep flashing when you hit signal silence. Any other point type will shut the whole NAC circuit down and everything will stop flashing and the horns will stop horning. The horns is if you use a different type of point type, the if you use a different type of point type, the strobes will stop flashing and you won't get any sound out the horns. So what you would want to do is make sure all of your NAC circuits have the same point type. Genesis silenceable, Genesis silenceable, and then the last one also Genesis silenceable. So now you could also put the description because if let's say your NAC circuit, the first NAC circuit is on the first floor east wing. It's serving that whole first floor east wing, and then NAC circuit is serving the first floor west wing. And NAC 3, second floor east wing. And NAC 4 will be second floor west wing. So now that we have the NAC circuits configured for Genesis silenceable and we have the descriptions, so if any of the wires break, if there's a problem with any one of them NAC circuits, you'll know which area that NAC circuit is serving. So now that we have zones we could skip. We don't use zones. You can use zones, but I only use zones if I need to. So I'm not going to put any of these devices into a zone and try to manipulate a zone or do some other type of correlation groups. I'm going to just skip past zones because we don't need it for this particular example. Correlations, we don't have any devices, so we can't do any correlations yet. Once we add devices, then we could come back and add some correlations. Same as the user keys, we don't know exactly what we're doing because we don't have any devices, nor do we have any correlations. So we're going to move on to that. Central station, we're not connecting this to a central station, but here in the telco account one is where you will put your 4-digit account number, your primary, and your secondary receiver. And also if it's reporting by device, by zone, or by event. Usually we would report it by device type. That's contact ID. So every point that's installed on a fire alarm control system, contact ID is identify every device that's on a fire alarm system. So if it's device 1 all the way to device 100 and whatever that description is, it will be sent over to central station. Then we have communication. Communication is how we connect to the panel. You will always want to read from the panel. Unless you have a brand new panel and you just finished writing the program, you can then write to the program. But if you're coming up on a system and doing some service, make sure you logged in level 2, and you want to read from the panel, even if you have the latest and greatest software, because you never know, somebody could have came out there a week prior and made some front panel adjustments, and you may not have that front panel adjustments if you just have the laptop. So moving on to events, don't worry about events. We could move past that. That's more on advanced level, how the signals get sent to central station. We don't have a printer, so we're not hooking up a printer, and we don't have any enunciators, so we're not hooking up any enunciators. So now devices. When we get down to devices, we have configuration, and then we have map. We always want to enable the mapping. It's always going to be a class B because the wire runs out and then it stops at the last device. So when we go inside of device configuration, we now will look to see how we're going to add these devices to the fire alarm system. So at this point, you'll be looking at your drawings because the electrician probably gave you The electrician probably marked up the drawings, put all the serial numbers on the drawings next to where the location of the devices are. So you know how many devices need to be put into the software, and you know what the messages are for these devices. So for our particular imaginary example, we have two smoke detectors, one single input module, and one smoke detector, and we also have one relay. So how we would add that is we have the smoke detectors are PSs, but now they're different point types, the OSDs. So you can tell this is a very old type of system. So PS is for the photo smokes. So we want two photo smokes. So when you see up here the top left where it says quantity, you can check off as many as the loop can handle. So all we need is two smoke detectors. So we're gonna come down at the bottom left and click on add device. So now we have two smoke detectors. And also now we said what a single input module. We have to go over to the modules tab, and then we have to come down and find a CT1, which is right here. So we got a CT1, we select the quantity of two, we click add device, and we're using M278 pull stations. So we're gonna click on, you see this 278 right here. So we're gonna click on that 278, and we got two pull stations. We're gonna add that device. You have to, if you want to, I made a mistake. You see, I'm still selected here on 126. So if I want to add the device, I have to select the next new available slot. So now that I have the next new available slot, I could add the device. And we also need a relay, which is going to be a CR. Now we're using the CRHs for high voltage, so you can connect 120 volts to the CRHs. The CRs is just all low voltage, dry contact. So we have one relay, and we're going to add that device. See, keep making the same mistake. So we select the next available slot, add the device, and boom, we got those two relays inside there. One relay is going to be for door control. The other relay is going to be for fan shutdown. So the first CT1 is a water flow. So we want to select the water flow point type. The second CT1 is going to be a supervisory because this is inside of the sprinkler room. And then we have the two pull stations. We can leave that point type as it is. Now, the relay non-silenceable and the relay non-silenceable latch, if you want to use the function keys 1 or 2, you have to put it on relay non-silenceable latched in order for you to hit that button to release the relay. So on a point type for the control relay, you have two different types of point types, relay non-silenceable and non-silenceable latched. Now, what this means is when a fire alarm control panel resets, if you have it on non-silenceable, the relay will automatically go from closed to open, or go back to its normal state once the system reset. If you have it on latched, the relay will stay engaged until you hit a secondary button, like a fan restart button, in order to release the relays to start the fans or whatever operation you have to do after that. And relay silence, I have no idea what that is. We have to look that up to see what that is. I'm not going to even lie to you. So we're going to put some descriptions in here. Basement. And I like to use all caps. Also with the supervisory, there's a couple different point types inside supervisory. We have remote drill, remote reset, remote signal silence. Since this is a CT1, it could cover multiple different point types from smoke, pull, any. You can hook up non-addressable devices to a CT1. That's what I'm using it specifically for, water flows and tampers. But when you have the supervisory latching and non-latching, same as the relay silence and relay silence latching and non-latching, the supervisory if it's supervisory latching and a sprinkler tamper goes into supervisory, you will have to physically reset the system once that supervisory is clear in order to reset that trouble signal or that supervisory signal on the fire alarm control panel. We usually put non-latching, so if it's once it clears, it resets itself automatically. So we leave it at this point type. So if you're let's say if you're testing a tamper switch and you hit the lever and you hear it beep, okay, we know that it active. We know that it went active, and we know that when we get back to the panel, if we set the tamper switch back right, it will be clear. So let's label the rest of these devices. So now that we have our modules addressed, labeled, and when you look over here to the right side and you're going through your drawings because the electrician gave you the drawings with the serial numbers, each one of these devices, you will put the serial number inside of this box here. So that way it knows that this relay for fan shutdown is whatever that serial number is. So you put all your different serial numbers inside of the serial number box for each and every device. How I like to do it is once the system is installed and it's powered up, we turn on the system, we plug in all the wires, make sure all the wires is clear, plug the wires into the data loop, let the data loop find all of the devices, let it map all of the devices, give it the addresses. Once it's finished, then you upload the loop. Once you upload the loop into the map, from there you can make every point type available inside of the programming menu. And all you have to do is just put your messages one or messages two, however long the message is. Smoke detector. So smoke detector, we're gonna have one basement above FACP. And this one is gonna be first floor elevator lobby. So now that we have our devices installed, and we have our devices programmed into the system, we will have a map. But this map doesn't have anything because you have to be connected to the panel and you retrieve the data. Once it retrieves the data, then you will have devices lined up one after the other, what is in front and what's behind each other. So what we want to do now is go back to correlations. So now that we have correlations, we're going to be looking at our drawings, and the drawings is going to tell us how we're going to program this. How we're going to find that information out is looking at the sequence of operations. That will be that small box with lettering to the left and lettering up to the top, maybe on a diagonal slant, maybe on a 45 degrees. And also inside the box, it would be like a grid with dots inside of them, letting you know that the smoke detector should enunciate a signal. It should send a signal to the central station. It should also turn on the horns and strobes. It is given all the functions that each particular device should be doing. So we know that pull stations will release the doors. We know that the water flows will release the doors, also shut the fans down, also um, release the elevators, elevator recall. So generally, how we would normally do this is start with correlation one, and I like to label everything. So I put this as general alarm because this mean that all the alarm types will just turn on the horns and strobes generically. I'm not doing any special functions or anything like that. Any alarm type device will set the alarm on. So we can highlight everything, but remember we have a tamper switch involved, right? So we don't want to bring over the tamper switch. So we just highlight the first three, then we bring it over, then we go to the fourth one. And what I'm doing is holding shift and clicking, and then we send everything over. And over here, since it's down at the bottom on the output side, we want to activate. I don't want to activate the relay sounders. I don't care about that. And I don't care about modules. This is just a general alarm. So I want to activate all of the DAC circuits only. So now this correlation group says when any smoke detector, when any one of these two smokes, this water flow or any pulse station activate, these outputs are going to turn on. So now we have the general alarm group done. So now the next thing we're going to do is door release. So we're going to label our correlation. The only thing that releases doors is pull stations, water flows, smoke detectors. So pretty much. So now another thing I want to add to the general, another thing I want to add to the general alarm category will be door release. I don't want to add fan shutdown because the pull stations are inside of this group. So all I want to do now is just add the door release. I'll have door release. So scratch that. So we got his elevator recall and fan shutdown. So no door release. So this next correlation would be fan shutdown. And why we didn't put it in the first group is because the pull stations are in that group and pull stations don't shut the fans down. So we got two smoke detectors and we have this, what is this? This water flow. These guys will shut the fan down. So all I have to do is find the module for the fan and bring it over here. So now this is my correlation for fan shutdown. Now the next one after that will be elevator recall. And I like to separate my correlations so that way I know what each one is doing. It's easier for troubleshooting. So now what's going to recall the elevator? The elevator lobby smoke and the water flow. And we're going to have this module here recall the elevator. So now we have our three different types of correlation groups. So now when we download to the fire alarm control panel, the smoke detectors that's installed, these devices that's installed will turn on the horns, all four of the horns and strobes. It will shut the fans down, the point types that need to, and it will also recall the elevator. So this is how you would program a typical basic fire alarm system when it comes to either the Edwards IO panels or either the Kitty VS for one, either the Kitty VS panels or the Edwards IO panels is pretty much identical. But when we get into the Edwards EST3, I'm going to show you programming rules. Totally different than drag and drop correlations. You actually have to write out what you want the system to actually do. So this has been an overview of how you can add a panel to the fire alarm control. So this has been an overview of how you can add a panel to the Edwards IO. So this has been an overview. So I just showed you how to add a panel, add some devices, do a little bit of correlations inside of the Edwards IO configuration utility. If you have any questions about programming, let me know. I'm here to help you. Peace.